last year in 8th grade, we learned scatter plots, right? And we used a line to predict, like, oh, well, based on the trend line. Well, this was actually during the 4th 9 weeks. I don't know. No, actually, no, we learned everything before we had left for COVID. So, yeah, so the trend line, we used the trend line on a scatter plot to figure out, like, to predict, like, okay, if I had gone this many miles, how much is this, or something. So we used the trend line to make a scatter plot, or to see, like, the middle information, the best line that fit in the scatter plot. So it was like in the middle of all of our data, blah, 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 blah. But we never could get the most accurate trend line. Remember, like, sometimes, like, is this a good trend line? Is that a good trend line? Well, linear regression, we're going to use our calculator to find the actual trend line, the line that best fits our scatter plot data, or that best fits a set of data. So we're going to find the equation where we can write an actual y equals mx plus b accurate equation. And like I said, the calculator is going to do it for us. It takes no work except to plug it into the calculator. And we're going to find something called R, which is our correlation coefficient. Those are the two things that we're learning. How to plug it into the Desmos to give us the linear regression equation, and the correlation coefficient. This will tell us how strong our trend line is, like how well does it fit our data. And we'll go into that in a moment. So if I was to write a definition of linear regression, it's the equation of the line that represents the line of best fit. So linear regression, if I was writing notes, I would say linear regression equals line of best fit. That's how I would write my notes. And then I would draw a little scatter plot so I know what it's talking about with the line. Hmm? Really? Ouch. So our linear regression line is our line of best fit. Well, our line that best fits our data, our scatter plot. Again, we're not going to do this by hand. We're just going to let Desmos tell us and explain how to do this. If you had me last year, we've actually done this before. We just didn't do it for scatter plots. So linear regression equals the line of best fit for a scatter plot data. So I'm going to show y'all, I think it's a table first. Yeah. So we're going to use this table, and we want to find the equation for this table. So we're going to have to use Desmos. And don't worry, you don't have to go to Desmos. I'm going to pull it up on here on Nearpod. We're going to put this table into Desmos and let it give us the line that best fits the data. Here's my question. Is this table a function? Why not? Yep, there's two -6s. That -6, that x value has two outputs. Therefore, it is not a function. So we know it's not a function. So we're going to put this into Desmos. We're going to insert the table. And then we're going to write this equation so that it can give us our slope and y-intercept. y1 squiggle mx1 plus b. So in Desmos, we're going to put that table in. I'll tell you what the numbers were because obviously it's not on the screen anymore. So press this plus sign at the top left-hand corner. When you hit that plus sign, the word table is going to pop up. Press table. So this should be on your screen as well. So we press the plus sign, went to the word table, and we're going to put the table in. So when everyone gets there, then I'll start saying the values. So the x values are -2, -4, -6. Oops. What in the world is going on? Sorry. Okay, -2, -4, -6, -6, -8. Remember, the negative sign is just the minus sign. Then the y values, 7, 9, 10, 12, 14. If I look, here's my scatter plot. So if I understand this, I cannot draw a line through this where it's going to hit every point, a linear line. So I need to find the line of best fit. Well, Desmos will give me the line of best fit. If I need you to make sure you write this little line of best fit equation down somewhere so that you remember how to use it. So it's y1. So I'm going to bring up my keyboard so that y'all can see it. So y1. And then if I go to ABC over here, I press this squiggle next to the comma, this little squiggle line. Y1 squiggle M X1 plus B. I hope so. So if you notice, a line pops up, and this line is the line that best fits my data. Now, let me explain. Why do you think I'm putting Y1 and X1? What does the table say for X and Y? It gives the number X1 and Y1. It has to be able to read the table, so that's why I put that subscript here. So I wanted to read these X's, so I have to say X1. I want to read these Y's, so I put Y1. So Y1 squiggle MX1 plus B. Write that in your journal because you're going to use it over and over again, but also do it yourself. So Y1 squiggle MX1 plus B. That squiggle has an actual name. I just don't remember what it is. So if you're confused what to write, in your notes, we did Y1 squiggle MX1 plus B. So if you notice, what is this giving us? This information, what did it give us? So it gave us M, and M represents what? Slope. And it gave us B that represents, okay, so it gave us a slope of, I'm just going to round to nearest hundredths place. It gave us a slope of -1.13, and it gave us a y-intercept of 4.5. So since it gave me a slope and y-intercept, what's my equation then? Y equals -1.13 x plus 4.5. This is my equation for the line of best fit. This is my linear regression equation. That was a really good outfit. So this is my linear regression equation. Also notice it gives us these things called R. We don't care about R squared. What we care about is the R value. It gives us an R of -0.96. And I'll explain what the R value means. But I just wanted to write that down as well. So it gives us an R value of negative 0.96. So this is definitely not meant to be hard. Basically, put the table into Desmos, let it give you the equation to the line of best fit. And then we're going to talk about what that R value means. So look at this. Look at these graphs real quick. Look at these graphs and look at the number that's underneath the graph. Look at the graphs. And look at the numbers underneath the graphs. I want you to see if you can make any observations. Just look for now. I'll ask what you think in a moment. Boy. Hey, Alexa. All right, let's finish. Let's finish. All right, look at the graphs. I want you to not say anything about it yet. I want you to see if you can figure out the pattern. There's a certain pattern going on with the number it's associated with and what the graph is looking like. So just try to make some observations. Now, what do you think?
So like the first three, they're going up.
Mm-hmm.
And they're positive, and the middle one's like scattered.
Mm-hmm.
That's why there's no number. And the other ones are like looking like they're going down.
Mm-hmm.
That's why they're negative.
Okay. Great observation. So the numbers that are positive have positive slopes, and the ones that are negative have negative slopes. Awesome. Any other observations? Hmm.
Oh, that's what. Yeah.
What do you notice as it's get? Huh?
Like the one, like the positive one and the negative one, both are going at first, like in the actual first one.
Uh-huh.
You can actually, what is it called? You actually make your own.
Yeah, great observation. Keep going.
That's about it.
All right, so the ones that say 1, man, I can put a straight line through these. These are perfectly in a straight line. And if you notice, it's perfect correlation. But as I get closer to 0, what's happening to the graph? It's getting more and more scattered. The correlation is getting less together. Yeah. Right? Oh, it's keep getting more spread apart. And then 0, that don't have any pattern at all. It's not positive, negative. They're just all over the place. So what I want you to notice is that the closer the number gets to 0, the less the correlation. And if I was writing notes, correlation is the relationship between X and Y. So the correlation is the relationship between X and Y. The relationship between X and Y. Or down here, the correlation, so the correlation coefficient, the R value, tells me how strong my linear regression line is. The R value tells me how strong the linear regression line fits the data. So 2 big things I would write down. Correlation means relationship, and the correlation coefficient is how strong the linear regression line fits the data. So if I was writing 2 things down, correlation means relationship between X and Y, and the correlation coefficient, that R value, is how strong the linear regression fits the data. So we're going to look at exactly what R value means what. Regression. So how strong the linear regression line fits the data. So if I look at these, I definitely do not want you to write all this down, but I want you to notice it either can be weak, moderate, strong, or perfect. If my R value, positive or negative, is between 0 and 0.33, it's to be weak. It's weak data. The points are super scattered. The relationship between X and Y is super weak. But it still gives you some kind of pattern. You can still notice either a positive or negative trend. If my R value, positive or negative, that absolute value saying positive or negative R, is between 0.33 and 0.67, it's pretty moderate. It's like, it's pretty strong, but not, it's not strong, but it's not weak. It's in the middle. Then really strong data would be between 0.67 and 1, meaning that that relationship between X and Y is pretty strong. Those points are pretty tight packed and close together. And then one that is 1 is a perfect correlation. It's a perfectly straight line. Yeah, I mean, usually, right, when we're doing this, so far this year, we've only had data that's perfect, right? Because we can write an equation from a perfect data. Today, we're starting to look at, okay, well, what if my data is more scattered? But the big questions you're going to see on the test is, what is the correlation coefficient and what does it mean? Oh, 0.99? Oh, that's positively strong correlated. Oh, 0.03? Oh, that's weak. You know, so understanding whether it's weak or not. So positive R means it's a positive slope. A negative R would be a negative slope. That's one thing to also remember. I said this one was kind of weak right here. Linear regression. Regression. Linear regression. You're welcome. So we're going to look at some graphs, and I want you to match the graph with what R value you think it goes with. So I'm going to give you about 1 minute on your Nearpod. Match the graph with which R value you think it goes with. Sure. I don't know if you can see that though. So this says graph A, B, C, and D. Y. Y7, D, 9, E. Y7, D, 9, E. All right, 30 more seconds. Draw so all I want you to do is, okay, R equals -1. I think it goes with this graph or whatever. I mean, no, it should be somewhat accurate. It's okay. I'd rather you try than anything else. Yeah, we do good things. After I do the lesson, we can do good things again. Okay, Jada, what do you think R equals -1? Which graph do you think it goes to? B. Absolutely. B is a positively negative, not positively negative, a perfectly negative regression. It goes in a perfectly negative straight line. Perfect, that's straight, right? Right? Okay, whatever. I can't go through the dots, but you know what I mean. It's a perfectly straight line. Okay, Jaden, what do you think R equals 1 goes to? Hey, absolutely. It's a perfectly straight positive line. Noah, what do you think R equals 0 goes to? What do you think R equals 0 goes to? Which graph? Absolutely, because C doesn't really have a pattern. It's going down, but it's also going up, and then there's some random dot right here. And then R equals negative 0.7, we'll go with D. I think this data is a little too scattered to be this strong of a number. I would say more like maybe 0.5, 0.6 really for this data, but hey, I'm just, you know, a teacher. All right, let's try this one. Oh, babe. So let's match the graphs again. I don't think I agree with the numbers again, but it'll be obvious which ones go with which. We already knew that. I'm sorry. So this is B, this one says C, this one says A. All right, Alexa, graph B, which R value do you think it goes with? Yeah, so this is the only one that had a negative R value and it has a negative slope. So that one had to go with that one. Even though, again, I think this could be a little, maybe a little bit more compact. But hey, all right, graph C. Sophia, which one do you think goes graph C? Absolutely. And I could kind of use process of elimination because this one is tighter. And so this one looks stronger. So 0.96. Awesome. So this is the last thing we're doing is we're going to use our linear regression equations to answer some questions. I'm going to skip this one and we're going to do this graph first so that we can go a little bit faster here. So this graph, we need to figure out the line of best fit. Well, we need to figure out first what each point is. So what is this point right here in the bottom one? What? -5, -1. All right, what's this one? -5, 1. This one? -3, 1. This one? -2, 3. This one? -1, 5. Jada, do you know how to read your ordered pairs? Do the rest, Jada. Oh, okay. Okay, good. Uh-huh. All right. So we're going to use these points and put them into our Desmos table. So let's add a table, plus sign. So do this with me, because if you're just watching me, you ain't going to remember how to do it. Press plus sign and then table. We're going to put the X and Y coordinates in. So the first one was -5, -1. That was our first order pair. -5, 1. -3, 1. -2, 3. -1, 5. 1, 5. 1, 7. 3, 9. So put in all those points. Okay, how do I get it to give me the line of best fit? What do I do? All right, y1, squiggle, m, x, 1 plus b. Yeah. So perfectly, Jada, do you have your iPad? Okay. Okay. So this line is perfectly in the middle of all your data. It looks great, this linear regression line. But so what is the R value? 0.9. So does that tell me it's strong, medium, or weak? Strong. So that's close. That's super close to 1. All right, that's very close to 1. So that is strong data. Strong data. What is the slope that it gives us? All right, I'm gonna just round to nearest tenth place. So I'm gonna be y equals 1.1 x, and what is the y-intercept it gives us? All right, so 5.3. So here's my linear regression equation, the slope of 1.1 and a y-intercept of 5.3. Okay, we're about to use this equation to answer some questions. So write this equation down so you have reference to what this is. We have one more slide left, one more slide. Okay, so here are the 2 questions that we have left to answer. So I want to know what, let me rewrite the equation. It was y equals 1.1 x 5.3. Thank you. Oh, wow. All right. So use the linear regression equation to find f of 3. What is f of 3 asking? What is y equals something? Close. So the 3 is replacing the x in f of x. So this is asking when x is 3, what is y? So what am I going to do with the x value here? Yep, so I'm going to replace that, substitute it with a 3. So f of 3 equals, I don't know. I don't have my calculator. Yeah, I do. Here it is. So 1.1 times 3 plus 5.3 will give me 8.6. Okay. The second question says, what is f of x equals 9? What is that asking? Y equals 9, so that's asking for x. So I know it's saying y equals 9 because if I remember f of x, the whole thing represents y. So this is saying, well, when y equals 9, what is x, question mark? So I'm replacing y with 9. No, I gotta find x. Oh. Well, how do I find x? How? All right, subtract 5.3 from both sides. So 9 minus 5.3 is 3.7. And then what? By? Yes. And I'm going to divide both sides by 1.1. So that will give us 3.36 equals x.
His math is awesome.
3.36 equals x. Okay, you need to know how to do both of these things for the task today. What?